Question 29 on the math subject GRE practice test. This is an awesome question and it's placed very well. I just finished making solutions to question 28, and it's hard for me to imagine finishing 28 in any reasonable amount of time during the pressure of a test. If you had finished question 28, you'd probably be pretty concerned about the time that you have left for the test, and there's nothing that would make you happier than question 29 here. Because this is a question, if you really hurry, you can knock out in a minute. So what's going on here is we have this function f, and it's defined as an expression containing an integral. And what we're asked is about when this function is increasing. So hopefully when you see the word increasing, you're thinking f prime of x, the derivative, must be greater than 0. So when you see this problem, you're probably just thinking, all right, what's the derivative of this expression? Well, great news. When you have the derivative of an integral, there's this thing called the fundamental theorem of calculus that comes in really handy. I guess really the fundamental theorem of calculus has two statements, but one of the two statements essentially tells us that the derivative and the integral kind of cancel out. They're kind of sort of inverses of each other. To make that a little bit more formal, I'd say when I'm taking the derivative from any constant, 0 in this case, but really any constant will do, up to my variable x of some function, maybe I'll just call it f of y, this derivative and this integral kind of sort of cancel out, and I'm left with just f of x. In other words, rewrite the integrand, but change the variable into whatever letter you see up here. If this isn't just your variable, if this is a function, then the chain rule comes into play and it's a little bit more interesting. But I think I've already done that in another video, so I won't bother rehashing that because it's not relevant to this problem. What I'm saying is this derivative and this integral basically just cancel out. And f prime of x is equal to the cosine of x raised up to the 23rd power times 2 plus the sine of x raised up to the 23rd power. I just want to know, when is this thing increasing? In other words, when is this thing, the derivative, greater than 0? Well, let's see, if you're multiplying together two things, it's going to be greater than 0 if both of those things are positive or if both of those things are negative. But this thing's never going to be negative, right? Because sine of x is a number between -1 and +1. And when I raise some number between -1 and +1 up to the 23rd power, I get a number that's between -1 and +1. And when I add 2 to a number that's between -1 and +1, I'm guaranteed to get a positive number over here. So that tells me two things. That tells me I don't even need to consider the case where they're both negative, because that can't happen. It also tells me that I can essentially just ignore this factor because this thing's always going to be positive. I can answer my question by just figuring out, when is the cosine of x raised up to the 23rd power greater than 0? Well, the only way I'm going to get something that's greater than 0 when I raise some number to the 23rd power is if that number itself is greater than 0, right? The fact that this is an odd number allows me to say that this inequality is equivalent to the inequality cosine of x is greater than 0. Take the 23rd root of both sides of the inequality if you want. When is cosine of x greater than 0? Well, I don't know, unit circle maybe? There's a decent looking circle for any angle x. X coordinate of the terminal point is the cosine of that angle. The y coordinate of the terminal point is the sine of that angle. What I'm saying is that any angle that leaves me over here on the right side of my unit circle is going to be an angle such that the cosine of that angle is greater than 0. So while there's lots of possible answers, I bet the answer that they give is all of the angles from -π/2 up to +π/2, not including these points themselves, because at these points the cosine is equal to 0, not strictly greater than 0. Sure enough, that's answer B, which would be the answer to this question. You know it's a quick one when I never even changed the color of the pen.